A very warm welcome everyone. Today in this class, we will be starting a new chapter, Metals and Non-Metals, Unit 17 under the subject Science and Technology, Class 9. I hope you are prepared with all the notebooks and pens you need for this class. So without further ado, let's get started. So let us start. Before starting with metals and non-metals, let us understand what an element is. So element is any substance that cannot be broken down into smaller substance by any chemical means. So we can define element as a substance that cannot be broken down into smaller substance by any chemical means. And basically elements are usually categorized into three types: metals, non-metals, and the metalloids. So metals are those elements that possesses metallic properties, whereas non-metals are those elements that does not possess metallic properties. And there comes the metalloids, the third type of elements. The metalloids are those elements that has property that falls between the metals as well as the non-metals. So it possesses the characteristics or the properties of both the metals as well as non-metals. So basically there are three types of elements. So in the periodic table, you can see that on the right hand side, except the hydrogen, all the non-metals are present on the right hand side of the periodic table, where hydrogen is the exception. And in the left hand side, which is represented by this red color, you can see that there are all the metals. And in here, when we transition from metals to non-metals, we can see a few elements which are metalloids, that is present in between the metals and the non-metals. So in the periodic table, the elements metal, metalloids and non-metals are found in this way. Now metals. Some of the metals are also found in free states. A few metals such as the gold, platinums, etc. They are found in the free state. You can see here in the stone, you can see gold are present here. And from these stones, the metal gold can be extracted. So some of the metals are found in the free state, but most of the metals are found in the on the surface of the earth naturally in forms of ores. So it is combined with other elements as well. So here you can see in the figure, these are ores of certain metals. So in this way, metals are found. Now how we can extract these ores is the miners. They usually mine this ore out from the earth's surface. And you can see here in the figure, this miner has recently mined out a certain ore. So the ores that is mined out, what we do is, by the process of metallurgy, we can extract the metal from its ore. So metallurgy is the process of extraction of metal from its ore. And after the extraction of metal, it is used to make various substances that is necessary for commercial as well as domestic uses. But metals are not only found outside of our body. Some of the metals are also present inside the body, such as in our blood, there is a type of blood cell that is known as red blood cells, the RBCs. And inside the RBCs, we can find a metal iron. So this iron is also present inside the human body as well as body of animals. But not only that, in plant also, in the chloroplast of the plant contains chlorophyll, and that chlorophyll contains magnesium in it, and magnesium is also a metal. So metals are not only found in a free state or combined in forms of ore that is found in the earth. Some of the metals are also present inside the body, and a few examples of those are iron that is present in animal's body, as well as magnesium that is present inside the chlorophyll of many plants. Now, you must be wondering how we can differentiate metals from other elements, the metals and the metalloids. So how can we differentiate if a certain element is a metal or not? So there are certain properties of metal that you must keep in mind so that you can distinguish if that element is a metal or not. So these are the basic list of the physical properties of metals which can be used to determine if that element we are trying to identify is a metal or not. So the first one is luster. The metals are lustrous, metals are usually hard, metals are usually sonorous, they are good conductor of both heat and electricity. Most metals are malleable, and most metals are also ductile, and metals have high melting and boiling temperature. Now, let us study individual physical properties of these metals. Now, let us study individual physical properties of metals. Now, the first property we'll discuss is luster. Luster is the shiny appearance of the metals. So, you can see here in the figure, these metals are shiny. When light is exposed on them, it reflects back the light. So, metals have shiny appearances, but non-metals usually are not lustrous. They do not have shiny appearances. But there are certain exceptions of non-metals that are also lustrous, that is iodine. Iodine have a shiny appearances, but exception cannot be taken as example. So that's why we say that usually most non-metals are non-lustrous. The another property is hard. Metals are usually hard. So since metals are hard, you can see that this man is using a metallic hammer to hit this substance. Similarly, since metals are hard, it is not easy to break a metal down. So you can see that when he was hitting this metal, it did not break down easily. Similarly, you can see that here, to cut this piece of metal, various instruments, heavy instruments, highly technological instruments are required, because since metals are hard, we cannot cut it easily as well. So most of the metals are hard and it cannot be easily broken down or cut or scratched, while non-metals are comparatively softer than the metals and they can be easily broken down. Now, why do you think that is the reason? Can you guess? Yes, it is because of a bond that is present in between the atoms of the metals. The metallic bond that is present in between the atoms that is present inside the metal, the bond is very strong. Since the bond is very strong, tremendous amount of energy is required to overcome the strength of this bond so that we can split the atoms and we can break the metal. So metallic bonds are stronger. So more energy is required to break this bond. That's why most metals are hard. But there are certain exceptions as well. Some metals like sodium and potassium, they are very soft and we can easily cut it with a knife, as you can see here in the figure. Whereas diamond, you all have heard that diamond is the hardest substance known to mankind, and that diamond is a non-metal. So these are a certain exception, but as I mentioned earlier, exceptions can never be taken as example. So even though some metals are soft, but most of the metals are hard. That's why we have a physical property of the metal, that most metals are hard. And even though diamond is the hardest substance known, the other non-metals, most of the non-metals are usually softer than the metals. That's why we say that metals are harder than non-metals. Now, the another physical property of metal is sonorous. That is, it produces sound when it is struck. You can see here in the figure that when we heat this metallic ball, then what happens? Sound is produced. Since you cannot hear the sound of this video right now, you can see that the water is being vibrated. That is due to the sound waves. So metals are sonorous. So when you go to the temple, what you do, when you ring the bell, you can hear the sound. That is, when you are ringing the bell, what you do, the metals, you are striking the metal. So a sound is produced. That is the sonorous property of the metal. Here I have this metallic bell. So when I struck this metal with another metal or anything, if you struck it with other thing as well, it produces sound. So this is a sonorous property of the metal. Now most of the non-metals, when they are struck, they do not usually produce sound. So metals are sonorous while most non-metals are not sonorous. Now the another important physical property is the metals are good conductor of heat as well as electricity. Now here you can see that this copper wire is conducting electricity, and the copper is a, what is a copper? It is the metal or a non-metal? Yes, copper is a metal. So since metal can conduct electricity because it contains large number of free electrons, and due to conduction of those electrons, electricity can be conducted. So that's why metals such as copper are used to make wires so that we can conduct electricity from one point to another. But whereas the non-metals, they do not conduct electricity. Have you ever seen a wood, which is a non-metal, used to conduct electricity between 2 points? No, because wood is a non-metal and it does not conduct electricity. So we can say that metal conduct electricity, hence we can use it as wire for electrical conduction, while the non-metals, they do not usually conduct electricity. Now here you can see in the figure that this girl is cooking and she is using a metallic fork while cooking, and all of a sudden she burned herself. Why? Because a fork is a metal and she is using a metallic fork, and when she was cooking, heat transferred from tip of the fork, and since metal is a good conductor of heat, so heat transferred from the tip of the fork and it reached her hand and she burned herself. So since metal, so from that also we can understand that metals are good conductor of heat. You can see that she is also using a metallic frying pan to cook, because since metals are good conductor of heat, it is also used to make utensils so that we can cook our food. And here you can see that the wood is burning. Now even though the wood is burning, and this non-burning side of the wood, if we touch it, we do not usually get hurt if it is not burning. Why? Because the wood is a bad conductor of heat. Even though it is burning on the front side, we can feed the fire and we can fix the wood in it, or we can push it inside so that the fire is more stronger, because it is a bad conductor of heat. So we don't really hurt ourselves while touching a wood that is not burning. Now the another physical property is malleable. So you can see here in the figure that when this metal is being hammered, it does not break while it is being changed into a thin sheet-like structure. Now this property of metal is known as malleability. So the property of metal which turns into a flat foil when hammered, and it does not break in that process when we are changing the metal into a flat foil, that property of the metal is known as malleability. Whereas when we strike a non-metal, then it usually breaks down into pieces. And here you can see in the diagram, this is an aluminium foil. Aluminium, is it a metal or a non-metal? Yes, aluminium is a metal, and you can see that it is being changed into a very thin sheet and it is not broken down. So this property of aluminium, that is a metal, is called as malleability. And since we can make flat foils of metals, it can be used to make various substances such as this utensils. You can see this frying pan is also flat on the base as well as on the edges, and this utensil is also flat on the sides, as well as its cover is also flat because it is malleable. So we can mold it into various shapes even though it is flat without breaking the metal. So that property of metal is known as, yes, malleability. Now another property is ductility, that is, metals are ductile. Here you can see that this metal is being formed into a this metal is stretched to form a thin wire. Even though it is stretched to form a thin wire, it does not break down. So this property of the metal is known as ductility. So the ability of a material or a metal to be stretched or pulled or drawn into a thin wire. By stretching and pulling, we can draw the metal into a thin wire without breaking it. That ability of the metal is known as ductility. And this property is due to the presence of the metallic bond. Since I also mentioned this previously, that when I was explaining that metals are hard, it contains strong metallic bond. Over here also, due to that strong metallic bond, the atoms does not break down easily, so it can be stretched to form a thread without breaking it. So this is also called as the ductile property of the metal, and due to this ductile property of the metal, we can make a thin wire out of it, like this copper wire and this wire, and we can also use it to make this wired fence, so that we can protect our house and by building all those fences. And since it is strong also, it is good to make this wired fences for protection. So metals are usually used due to this ductile nature. It is drawn into wire. Now, another property of the metal is it has high boiling and melting temperature. You can see here in the figure, this metal is being changed, this metal is boiling and it is in molten form, and you can see from the figure here that it is in very high temperature. So metals usually have high boiling and melting temperature, even though there are certain exceptions such as mercury. Mercury is found in liquid state even in the room temperature, but as I mentioned earlier, exceptions cannot be taken as examples. So most of the metals have high boiling and melting point. So why do you think that metal has high melting and boiling point? Can you guess? Yes, it is because in solid state, the atoms of the metals are closely packed. Here you can see in the figure, the atoms of the metals are very closely packed. And you know that in liquid state, the atoms are a little far away from each other, whereas in solid, the atoms are closely packed. So the atoms in the metals are closely packed. So to separate those atoms or to move them apart a little bit so that we can change it into liquid state, we need a lot of energy. So the atoms in the metals are closely packed. So we need more energy to move them apart, to move those atoms apart so that we can convert them into liquid. And to do this, a lot of energy is required. That is the reason why the melting and boiling temperature of the metal is very high. Now let us study about certain chemical properties of metals. So the first property that we will discuss here is most of the metals, when they are burned means in present there, they react with oxygen. When they react with oxygen, they form metallic oxide, and those metallic oxide are usually basic. Now let us write a few chemical reactions. So now let us take an example of the magnesium metal. So when magnesium, it is burned in the presence of oxygen, what it forms is metallic oxide. Now the valency of magnesium is 2 and the valency of oxygen is also 2. So it cancels each other, so we do not have to write anything 2 over here. So MgO. Now this equation is not balanced. Here we have 2 oxygen, but here we have only 1 oxygen. So if we place 2, the oxygen on both sides of the chemical reaction is balanced. Now here we have 2 magnesium, but here we have single magnesium. So after writing 2, this reaction is balanced. Now when magnesium reacts with oxygen, it forms magnesium oxide. Now let us taste that if this magnesium oxide that forms is basic or not. Now here we have a magnesium ribbon. Now what we are going to do is we are going to burn this magnesium ribbon. Now burning means reaction with oxygen. So that will form magnesium oxide. Now here we have magnesium oxide. Now we'll add a little bit of water and stir this. Now what happens is when magnesium oxide it reacts with water, it gives us magnesium hydroxide. Now let us taste if this is basic or not using litmus paper. Now this is a red litmus paper. Now you can see that the red litmus paper has turned blue. So from this we can say that the magnesium we burned has been burned after the reaction possessed basic property. Now let us test if this converts the blue litmus paper or not. Here you can see that the color of the litmus paper has not changed. So that means this is basic. So from litmus test, we can say that when magnesium it reacts with oxygen, it formed a metallic oxide which had basic properties. So we just studied that when magnesium it is burned in the presence of oxygen, it gave us magnesium oxide which was basic in nature. So let us recall that experiment again. So when the magnesium ribbon it was burned, the burned magnesium ribbon formed magnesium oxide and it was placed inside the test tube, and the oxide of magnesium we saw that it was a white powder like substance. So that is magnesium oxide. And what we did after that, we added a few drops of water in it so that we can dip the litmus paper. So what reaction occurs after that is, now we just studied like 2 mg this reaction. We just studied this reaction. Now this formed magnesium oxide which is a white powder, which when we added water, what happened? It gave us magnesium hydroxide. Now, what is the valency of magnesium? Yes, it's 2. And the valency of hydroxide? It is 1. So, we have to transfer this 2. So, it formed magnesium hydroxide. Now, magnesium hydroxide was formed, and to this magnesium hydroxide, we performed the litmus paper test, and we saw that the red litmus paper changed into blue, indicated that it was basic in nature. Now, we added a few drops of water, and it formed magnesium hydroxide. And when litmus paper test was done, the color of the red litmus paper changed to blue, indicating that it is basic, whereas the blue litmus paper did not change any color. That also proved that the magnesium hydroxide was basic. Now let us take certain examples of other metals as well. Now similarly, when sodium it is burned in the presence of oxygen, it forms sodium oxide. Aluminium, when it is burned in the presence of oxygen, it formed aluminium oxide. Iron, when it is burned with oxygen, it formed ferric oxide. And copper, when it is burned in presence of oxygen, it also formed cupric oxide. All these metals, when it reacted with oxygen, it formed respective metallic oxide, and all of this metallic oxide that I mentioned here is basic in nature. So most metals make basic metallic oxide when they react with oxygen. Now let us study another chemical properties, that is metals when they react with dilute acid, it gives us salt of that metal as well as hydrogen gas. Now let us take one example. Now what we studied was metal. Let us take an example of magnesium again. When it reacts with dilute acid. So dilute, let us take an example of hydrochloric acid. When it reacts with hydrochloric acid, what does it form? It forms the metallic salt. So this magnesium, what it does, it displaces the hydrogen that is present in the acid, and after displacing it, it forms the metallic salt. So it forms MgCl. Now the valency of magnesium is 2 and the valency of chlorine is 1. So after valency exchange, MgCl2 plus what does it give? It gives us hydrogen gas. Since hydrogen is diatomic, it stays in a molecular form. So we have to write H2. Now this is the reaction that occurs. Now the reaction is not balanced. So let us balance this reaction. So we have magnesium both 1, 1. Here we have 1 hydrogen, 2 hydrogen over here. So if we write 2 over here, the hydrogen is balanced on the both side. Now we have 2 chlorine and here we also have 2 chlorine. Now this is a balanced chemical reaction, and from this we can understand the chemical property of metal. That is, when metal it reacts with dilute acid, it gives us hydrogen gas and also forms a metallic salt. This is the reaction which you studied. When magnesium it reacts with dilute acid, it displaces the hydrogen that is present in the acid and forms the salt of that metal, that is NaCl2 in this case, and it liberates hydrogen gas. Similarly, another metal like aluminium, when it reacts with dilute acid, it displaces the hydrogen that is present in the acid and it forms salt of that metal, that is AlCl. The valency of aluminium is 3 and chlorine is 1. So AlCl3, and it liberates hydrogen gas. Similarly, when metal iron it reacts with dilute acid, it displaces the hydrogen forming salt of salt such as FeCl3, that is ferric chloride, and with the liberation of hydrogen gas. And when zinc it reacts with dilute sulfuric acid, it gives us zinc sulfate by displacement, and it also liberates hydrogen gas. And the final example here is magnesium. When it reacts with dilute acids such as nitric acid, it gives us magnesium nitrate, MgNO3 The valency of nitrate NO3 is 1, magnesium 2. After valency exchange, it forms the salt and with the liberation of hydrogen gas. So this is another important chemical properties of metal. Now let us study another chemical property, that is, when reactive metals like lithium, sodium and potassium, calcium, when they react with water, what they form is, they form the hydroxide of that metal, as well as they'll also liberate hydrogen gas. So let us study a few chemical reactions. Now, reactive metals such as lithium, sodium, potassium, what happens when it reacts with water? What does it form? It forms the hydroxide of that metal. Now, so what is the formula of the radical hydroxide? Yes, it's OH. Now, the valency of hydroxide radical is 1 and the lithium is, yes, it's also 1. So after valency exchange, it becomes LiOH. And what does it liberate? Yes, hydrogen gas. Now similarly, when sodium it reacts with water, it forms sodium hydroxide. The valency of sodium is, yes, it's 1 and hydroxide is also 1. So NaOH with the liberation of hydrogen gas. Similarly, it forms when potassium it reacts with water, it forms potassium hydroxide. The valency of potassium is also 1 and hydroxide is 1, and with the liberation of hydrogen gas. Now the reaction is not balanced because here you can see that there are 3 hydrogen at this side of the chemical reaction, but here there is 2. Now if we write 2, hydrogen becomes 4. Now if you write 2 over here, 2 plus 2, 4. So hydrogen is balanced. Now here we have 2 oxygen, 2 oxygen. Now here we have 2 lithium, but here we just have 1 lithium. So 2 lithium. Now the reaction is balanced. Now let's balance this. Here it also has similar cases. 3 hydrogen, 2 hydrogen. So if we write 2, hydrogen is balanced, 2 oxygen. If we write 2, now oxygen is also balanced, and sodium 2, 2. This is also balanced. Here 2 hydrogen, 3 hydrogen. If we write 2, 4 hydrogen. Now 3, 2 plus 2, 4 hydrogen. Now 2 oxygen, 2 oxygen, 2 potassium, 2 potassium. Now this is the balanced chemical reaction, and from this what chemical property we understand is when metal, it reacts with water, it liberates hydrogen gas and it also forms the hydroxide of that metal. This is another chemical property of metal. Now, these are the chemical reaction we just studied. Now calcium, when calcium is also a reactive metal, when it reacts with water, it forms calcium hydroxide as well as hydrogen gas. Now let us recall all the properties we just studied recently and compare the metals and properties of metals and non-metals. Now malleability. So which is malleable, metals or non-metals? Yes. Metals are malleable, whereas non-metals are usually non-malleable. We should always focus on the majority. We should never focus on the we should not focus on the exceptions, but the majority. So most of the metals are malleable and most of the non-metals are non-malleable. Now which is ductile, metals or non-metals? Yes, metals are ductile, whereas most of the non-metals are not ductile. Now, which conducts electricity better, metals or non-metals? Yes, metals. Metals are good conductor of electricity. That's why we use it to form copper wires so that we can transfer electricity in our houses as well as in the huge transmission line as well. So, metals are good conductor of electricity, whereas in non-metals are usually bad conductor of electricity. Now, heat. Which conducts heat more, metals or non-metals? Yes, metals. Metals can transfer heat, whereas non-metals usually cannot transfer heat. Now, which has a higher melting point, metals or non-metals? Yes, metals have higher melting and boiling point, whereas non-metals usually have lower melting and boiling point. Now, which is hard, metals or non-metals? Don't focus on the exceptions, because diamond is the hardest substance known, which is a non-metal, but that is a rare case, it is an exception. So keeping that aside, which is harder, metal or non-metal? Yes, metals are mostly hard, whereas non-metals are mostly soft. Now let us try to solve a certain questions and answers and check our knowledge. So here we have one statement and 2 arguments, and among these 4 options, one of them is correct. Now let us check which is the correct answer. Now let us read the statement. Metal have luster, but non-metals do not have luster. Is this true? Yes, it's true. Metal have luster, it has shiny appearances, but most non-metals does not have shiny appearances. Argument 1. Iron and iodine both are metal because both of them have metallic luster. Is this true? No, it's not true, because iron is a metal but iodine is not a metal. Even though both iron and iodine possess shiny appearances, but iodine was the exception. That is, even though iodine has a lustrous property, it is a non-metal and it was an exception. So this is incorrect because both of them are not metal. Iron is a metal but iodine is a non-metal. So the argument 1 is incorrect. Now argument 2. Sulfur and phosphorus are non-metal which cannot conduct electricity. Is this true? Yes, it's true, because both the sulfur and phosphorus are non-metals and it cannot conduct electricity as well. So the statement and argument 2 is correct. So the correct option is, yes, it is option 4, because the statement and argument 2 are correct. Now let us solve another question. So find the correct and incorrect arguments from the following. Here we have 4 arguments. Now let us see individually which is correct and which is incorrect. Now metals are placed at the right hand side of the periodic table. Is this true? Let me give you a hint. Now see, where are the metals placed? Is it placed on the right hand side or left hand side? Yes, it is present on the left hand side, not the right hand side, because non-metals are placed on the right hand side. So red colors are here, those are metals. So the argument was incorrect. Metals are placed at the left hand side, not the right hand side. So the first argument is incorrect. Now the second argument. When magnesium, it reacts with dilute hydrochloric acid, they form magnesium chloride and oxygen. Is this true? No, it's not true. Why? Because when magnesium, it reacts with dilute acid, dilute hydrochloric acid, what it does, it displaces the hydrogen that is present in the hydrochloric acid, and it forms the salt of that metal, that is magnesium chloride, with the liberation of hydrogen gas. So it does not liberate oxygen, it liberates hydrogen. So the second option is incorrect. Now the third argument, light metal such as sodium, when it reacts with water, it liberates hydrogen gas. Is this true? When the light metal sodium reacts with water, it liberates hydrogen gas. Is it true? Yes, it's true, because from the reaction here you can see that when sodium, it reacts with water, it forms hydroxide, that is sodium hydroxide, and it liberates hydrogen gas. So the third argument is correct. Now the final argument, metals are ductile, so they can be hammered into thin sheets. Is it true? No, it's not true. You might get confused because both these statements are correct. Metals are ductile. Yes, metals are ductile. And metals can be hammered into thin sheet. Yes, it can be hammered into thin sheet. But what is ductility? Yes, ductility is that property of the metal where it can be stretched to form a thin wire. And malleability is the property in which, what is that? Yes, in which we can hammer the metal to form a thin foil. But here what it says is ductility is a property where it can be hammered to form thin sheet. So that is not true. Even though metals are ductile, yes, metals are ductile, metal can be hammered into thin sheet, but ductility is the property of forming a thin wire, not by hammering and forming a thin sheet. So that is the reason why the statement is incorrect. In this class, what we studied about what is an element, the types of element, and how we can distinguish metals from other elements. So I hope you understood everything I taught in this class, and I'll see you in the next class.